Good evening, sir. Am I audible? Am I
Yes,
audible, sir?
yes, ऑडिबल।
Yes.
आज कौन सा टॉपिक करके आए आप?
सर कोऑर्डिनेशन का जो लास्ट पार्ट था, मतलब मैंने जो बेसिक थिंग्स था लास्ट पार्ट का, मतलब लेबाइल, इनर्ट
हमने
और
कहाँ
थोड़ा
तक डिस्कस
आउटर
किया था?
स्टेम।
लास्ट डे हमने कहाँ तक डिस्कस किया था?
सर लास्ट डे हम लोग ने लिगेंड फील्ड थ्योरी तक डिस्कस किया था, तो वहां पे मतलब स्पाइनल स्पाइनल तक हुआ था सर। स्पाइनल वगैरह हुआ था लास्ट तक, लास्ट।
स्पाइनल तक हुआ था, है ना?
यस सर।
केटीडी हम डिस्कस कर रहे थे।
यस। हेलो।
यस यस,
हाँ सर।
जेटीडी हमने डिस्कस किया था, उसमें स्पाइनल्स को डिस्कस किया था ना?
हाँ सर, जेटीडी जॉन्टेलर डिस्टॉर्शन डिस्कस किया था हमने, और मतलब स्टैटिक डायनेमिक ये सब डिस्कस किया था। ऑलमोस्ट सर कोऑर्डिनेशन का जो बेसिक बेसिक पार्ट था हो गया। इतना दूर तक तो मतलब डीप तक तो नहीं जाएगा शायद, फिर भी
नहीं,
मैंने देख लिया वो
नहीं,
सब।
मैग्नेटिक।
सर मैग्नेटिज्म का नहीं हुआ था। यस सर।
ऑर्गल डायग्राम, टेगनोसिग्नल डायग्राम, ये सब हो गया था।
हाँ सर, मतलब ऑर्गेल टाना भी आपने पूछा था, और बाकी मतलब ये मैग्नेटिज्म नहीं पूछा। और सर ये जो
मैग्नेटिक
था
है, यस,
क्या बोलते हैं।
मैग्नेटिक और रिएक्शन मैकेनिक, दो चैप्टर तो बाकी हैं। मैं पहले की बात कर रहा
हाँ
हूँ,
हाँ।
इससे बिफोर।
नहीं सर, बाकी तो सर
थ्योरी
मतलब
तो सारा हो
वो
गया,
मतलब
थ्योरी
हो गया।
थ्योरी।
हाँ थ्योरी हो गया था सर। हाँ सर।
कलर्ड स्पेक्ट्रा, डीडी टाइंसन, चार ट्रांसफर स्पेक्ट्रा।
हाँ सर, मेटल लिगेंड ये वगैरह मैंने बोला था। लिगेंड मेटल सब्सटेंस पर ये वगैरह। हाँ ऐसे है।
Yes. First go through one topic. Next is point number 6 is magnetic. What the main application of magnet?
Okay. Yes, sir. Uh, from the magnetism, we come to know about the that means those substance which attracted or repel by magnet. Basically, we can identify those substance with the help of magnetism character. That means if the substance are uh, strongly attracted by magnet, then it is called paramagnetic substance. And if the substance or complex are that means repelled by magnet, then it is called diamagnetic complex. Yes, sir. Yes.
What the difference between paramagnetic, diamagnetic?
Yes, sir. So paramagnetic substance in which there is one or more than one unpaired electron is present, then it is called paramagnetic substance. And if there are all the electron are paired, then it is called diamagnetic substance. Okay. And paramagnetic substance are attracted by magnetic field or magnet, and diamagnetic substance are repelled by magnet. Yes.
Yes, example of paramagnetic, diamagnetic.
Sir, paramagnetic substance, one
Antiparamagnetic.
example. हाँ sir. Paramagnetic substance are that means example. I can give example of that means NiCl4 2 minus. NiCl4 2 minus complex is paramagnetic complex, whereas the NiCN4 2 minus NiCN4 2 minus complex is diamagnetic complex. ठीक है, diamagnetic complex. And antiferromagnetic complex are those type of complex in which the that means the spin that means electron spin are arranged in such a way that all the spin are paired in those substance, then it is called antiferromagnetic substance. Antiferromagnetic substance, I think one example is manganese dioxide, I think. antiferromagnetic example one is manganese dioxide, I think. Is it correct? I don't think so. Manganese dioxide or sir, I think Fe3O4. Fe3O4 is one of the example of antiferromagnetic complex. And ferromagnetic complex are those substance in which the electron spin are arranged in such a way that it has remained some unpaired electron in it. Then it is called then it is called ferromagnetic substance. Okay, so ferromagnetic substance is manganese oxide. Ferromagnetic, I think. Sorry. Antiferromagnetic is manganese oxide, and ferromagnetic is Fe3O4. Is it? I think. Ferromagnetic, हाँ, वही है. Is it correct, sir? That means antiferromagnetic is manganese. Antiferromagnetic is manganese dioxide or nickel oxide, or ferromagnetic is iron Fe3O4. Fe3O4, that is magnetite. Magnetite is an example of ferromagnetic complex. Ferromagnetic substance, basically.
क्यूरी लॉ और नील टेम्परेचर में क्या डिफरेंस है?
Sir, Curie law at that temperature where antiferromagnetic, that means antiferromagnetic substance का कुछ था ये Curie law में, और नील टेम्परेचर तो सर फेरोमैग्नेटिक का था.
मैग्नेटिक मोमेंट क्या है?
I did. So magnetic moment is equal to magnetic moment का formula mu is equal to root under n into n+2. That means all the electron which are spinning around the nucleus, they give magnetic field. Okay, so the whole magnetic field is called magnetic moment. That means mu, we can calculate magnetic moment by mu is equal to root under n into n+2, where n is equal to number of unpaired electron. Yes, sir.
Magnetic moment. Yes, what is the formula of magnetic moment for transition element and lanthanide actinide?
सर ये तो लैंथेनाइड एक्टिनाइड का सर रूट अंडर L into L+1. No, sir, I have forgot the thing. सर कुछ G का था सर, कुछ G plus something था. और सर ये तो normally तो it is root under n into n+2 this is, but for this one I think mu is equal to, no sir, I have forgot that one.
mu is equal to G root J+1.
हाँ सर, ये G का कुछ था, G root J+1.
Yes, F block element.
G
yes.
F block element, yes sir.
D block
G तो
element
सर
is due
ये
to spin only. Yes, magnetic moment is due to spin only. D block element. Yes, US is equal to root n n+2. F block element magnetic moment presented due to spin plus orbital motion. So mu is equal to G root J+1.
हाँ, yes sir. हाँ sir.
How many factors present in magnetic to determine the magnetic moment?
how many factor present? That means, sir, only number of unpaired electron, I think. Number of unpaired electron and the motion of electron. That means orbital motion of electron. I'm not getting. That means number of. तो इसका आंसर क्या होगा?
Yes, number one magnetic moment due to the unpaired electrons. Yes, 5 factors.
Yes, sir.
Number of
Yes. Okay.
one is unpaired electron. Second is ground state term, change in orbital contribution, like to D4, D5, descent. Ground state.
Yes, sir. Orbital contribution that
yes.
one.
Triply generate, present in triply generate. Number two is number three is first perturbation theory. Number four is a spin crossover, high to low, low to high. Number
Yes.
5 is free ion complex and LS coupling complex.
Okay. Sir.
Yes.
Yes, sir.
Any drawback limitation of a magnetic moment?
Magnetic moment ka, sir, that means from magnetic moment, that means we can calculate that from valence bond theory. We can predict the diamagnetic and paramagnetic character, but no, sir, I don't know that one. I can any drawback or limitation. That means drawback or limitation to sir pata nahi hoga iska. Magnetism ka. No idea, sir.
No problem. Next, move on reaction mechanism, stability of reaction mechanism in coordination. Yes. How to determine the stability of complex in any reaction, thermodynamical stability and kinetically stability. How to determine?
Okay, sir. Okay, sir. Sir, those matlab complex, which give thermodynamic, that means which give a substitution reaction easily, they are called basically kinetic stability molecule, and those which are stable at higher temperature, then it is called thermodynamic stable molecule. Yes, sir. Those substance, that means which give which are stable at low temperature, or which give that means substitution reaction easily, they are called kinetically stable complex, and those complex which are stable at higher temperature, then it is called thermodynamic stability. Is it okay? Or kinetically stable complex are of two types: labile and inert complex. There are two types of kinetic complex, that is labile and inert complex. And we can say that means labile complex can be thermodynamically stable also, or inert complex can be thermodynamically stable also. We cannot predict, that means labile are thermodynamically unstable, inert are thermodynamically stable. We cannot say like that. Yes, sir.
Labile or inert, what's the difference between labile and inert?
Yes, sir. The complex in which substitution reaction occur repeatedly, they are called labile complex, and the substance in which substitution reaction occur, that means slowly, that means which takes more than 1 minute, are basically called inert complex. That means labile complex for substitution reaction takes only less than 1 minute, and for inert complex substitution reaction to take place around more than 1 minute. In labile complex, if the that means if the metal ligand bond are weak, okay, if the metal ligand bond are longer or weak, then if the electron in easy orbital, then it is basically called labile complex. And if the electron are basically in that means T2Z orbital or a low spin complex, then it is called inert complex, sir. Okay, inert complex or metal in which metal ligand bond are shorter, or metal ligand bond are shorter, then it is then metal ligand bond will be stronger, then it become inert complex. Yes, sir. Is it okay, sir?
Yes, okay.
Hmm.
Yes, how many factors affecting the stability of complex?
Stability of complex, yes, sir. There are so many factors, around 6, I think. One to, sir, nature of ligand. Okay, if the molecular nature of ligand, if the ligand are basic in nature, then it can donate easily electron to the metal, and then the bond becomes stronger. It can stabilize the complex. Or if the complex is that means covalent in nature, then the complex is also stable. If the and we also know that from HSAB principle, that means if the hard acid can combine with hard base, or soft acid can combine with soft base, that means if metal is in high oxidation state, metal is in that they are class A type of molecule, that means a hard acid. If metal is in high oxidation state, then it can bind with only hard base like ligand. Or if the metal is in low oxidation state, then it is soft acid, and it can bind with only soft type of ligand. Okay, and one factor is that is silation. If metal ligand with silating ligand, suppose I am taking ethylene diamine, which can form silation with the ligand, then the entropy will automatically increase, and then stability of the complex will increase. Okay, stability of the complex will increase. And another factor, that is, if the silating ligand has bulky some type of substituent in it, then the stability of the complex is reduced. Bulky substituent reduces the stability. Bulky substituent in the ligand reduces the stability of the complex. Yes, sir. Yes, sir. Almost I tell nature of ligand, that means metal charge, base, covalent character. Yes, sir. और एक फैक्टर था सर, भूल गया मैं, और क्या था मैंने बोला सर, दैट मींस नेचर ऑफ मेटल, नेचर ऑफ लिगेंड, सिलेशन, और कितना था सर, और 2 था शायद, भूल गया मैं। एक तो मतलब बाल्कीनेस इन द लिगेंड, देन इट विल डिक्रीज द स्टेबिलिटी। यस सर।
Nature of the central metal ion, chelate effect, resonant effect, nature of the ligands, macrocyclic effect, steric effect, steric hindrance.
Yes, sir. Steric effect. Yes, sir.
Yes, I explain one by one.
Yes, sir. That means nature of the central metal ion. If the central metal ion is in high oxidation state, that means it become that means hard acid. Then it can combine with only hard base like of substance. Okay, and if the metal is in low oxidation state, then it will become soft acid, and it will combine with only soft base. Okay, and if suppose the nature of ligand, one another factor is nature of ligand. If the ligand is in basic in nature, that means it can donate easily electron to the substance. If the metal is in basic in nature, it can easily donate electron to the metal, and then the metal ligand bond becomes stronger, on complex will become stable. Or if the metal ligand bond are covalent in nature, if the metal ligand bond are covalent in nature, then it will automatically become stable. Okay, then another factor is silation factor. If some silating group is attached with metal to form complex, then the entropy of the substance, entropy of the complex will automatically increase, and then the stability of the complex will increase. Okay, suppose I am taking Fe NH3 6. Here the ammonia ligand is 6. Okay, and again I am taking FeEN3, where En, ethylene diamine, is a bidentate ligand which can select the iron metal. Then due to silation, the entropy of the substance is increasing, and therefore the formation of this complex will become easier, and the complex will become stable. Okay, then another factor, that is resonance factor. Suppose I am taking acetyl acetonate molecule in which there is resonance effect, then this ligand can also stabilize the molecule. And one effect is macrocyclic ligand. Macrocyclic ligand effect, suppose I am taking in hemoglobin, in myoglobin, there is all the ligand are macrocyclic. That means porphyrin ring is present, where nitrogen can bonded the iron atom. The iron atom is 4 coordinated with the nitrogen atom. Then it also becomes stabilized due to the macrocyclic or due to the presence of macrocyclic ligand. Okay, the another factor, that is steric effect. That means if the silating group has some substituent attached with the donor atom or with adjacent atom, then this steric effect will affect the stability of the molecule due to repulsion. Okay, then the complex become unstable. So suppose I am taking 2,2-dimethyl 2,3-dimethyl ethylene diamine, or only ethylene diamine complex, then the ethylene diamine complex will be more stable than the previous one. Okay, that these are all factors which determine the stability of the complex.
Yes, good. Next is, what is Irving-Williams series?
So Irving-Williams series is basically that means it depend on, I have forgot that one. That means it depend only on the metallic stability. Okay, complex stability of the complex. This series give the stability of the complex ion. That means those substance, suppose I am taking barium 2 positive, calcium 2 positive, these all has CFSE equal to 0. Okay, these substance are become somewhat stable, but with the increasing, that means with the increasing of Z effective, the stability of the complex is increasing. Okay, with the increase of Z effective, that means effective nuclear charge, the stability of the complex become more easier, that means increases. Okay, this is called basically Irving-Williams series, where we can from there we can predict the stability of the complex. Basically, I don't know the exact explanation, but
No problem, you look them, you have to study. Yes, sir.
Yes, sir. I have to study that. मतलब एक बार पढ़ा हुआ है, बाकी एक बार रिवीजन देखना होगा सर. हाँ सर.
Next is, what is chelate effect?
That means, sir, chelate effect is basically if the ligand, I am taking the bidentate or polydentate ligand, which can donate through donate the which can bind the metal atom through two donor side and more than two donor side, then it can form a ring-like structure with the metal. Okay, this ring-like structure, due to this ring-like structure formation, the metal the complex become more stable. Then it is called Silet effect. This effect is called basically Silet effect. Due to silation, the complex ion or molecule, the complex molecule become more stable.
What the difference between associative or dissociative reactions in reaction mechanics in coordination?
If the reaction, that means which proceeds through that means association, or that means via SN2 mechanism, then it is called associative mechanism. Association, that means if some ligand attack the complex and then the reaction happen, then it is called associative mechanism. And if already the molecule, that means the complex already broken to another substance, then the reaction takes place, then the another ligand attack, then it is called basically dissociative mechanism. I don't know exactly, I have not read that, sir. I did not study that thing. That means associative dissociative mechanism देखा नहीं मैंने. तो
नो प्रॉब्लम,
आएगा या
देख
नहीं.
लेना, कोई दिक्कत नहीं है, सब हो जाएगा, अभी बेसिक चीजें हैं. ट्रांस इफेक्ट क्या है?
हाँ
ट्रांस इफेक्ट.
हाँ sir. Trans effect is basically the ligand trans effect is basically the ligand which determine the incoming nucleophile or incoming ligand, then trans to it, then it is called trans effect. Okay, the ligand, I am again explaining, the ligand which direct the incoming nucleophile to trans to it, then it is called trans effect. Okay, is it okay, sir? I like explanation.
Yes.
Trans effect का भी.
Yes,
sir.
cisplatin, transplatin, what the difference?
हाँ sir.
Cisplatin and transplatin, what the difference?
Yes sir. In cisplatin, the ammonia or chlorine bond angle is basically cisplatin has formula PTNH3 to platinum NH3 to Cl2. If the two ammonia ligand are in 90° or chlorine ligand are 90° to each other, then it is called cisplatin. And if the ammonia or chlorine are 180° to each other, then it is called transplatin. Yes, sir. Then it is called transplatin.
Any drawback, limitation of trans effect?
Trans effect only, sir. We can determine the trans effect only in only if we take the metal ligand bond in covalent nature, then we can predict the trans effect only. I don't think so that is the correct answer, but अब तो हमेशा मतलब लिमिटेशन पूछते
इंटरव्यू में यही पूछा जाएगा, इंटरव्यू में यही पूछा
हाँ
जाता,
सर.
इंटरव्यू में यही पूछा जाता,
हाँ
वो
सर.
पूछा जाता जो आप सोचते हैं. आपने देखा होगा इंटरव्यू ट्रांसक्रिप्ट, उनमें सब यही रहता है. थ्योरीज और
हाँ
ट्रांस
सर.
इफेक्ट क्या है? हाउ मेनी थ्योरीज इन्वॉल्व इन ट्रांस इफेक्ट?
सर एक था पोलैरिटी का था सर, पोलैरिटी ऑफ कोवेलेंट बॉन्ड.
पोलराइजिंग थ्योरी और पाई बॉन्डिंग थ्योरी, एक्सप्लेन कीजिए दोनों को.
पाई बॉन्डिंग थ्योरी सर, ये दोनों तो नहीं हो पाएगा अभी मुझे, मतलब देखना होगा एक बार. मतलब आज मतलब थोड़ा स्टडी कम हुआ है मेरा, इसलिए.
तो वहां पर कब जाएंगे? कल?
कल तो नहीं जाएंगे सर, मतलब मंडे जाएंगे, मंडे जाऊंगा. मतलब कल तो घर में रहूंगा ना, कल पढ़ूंगा सर, तो कल हो जाएगा ये सब.
कोई दिक्कत नहीं, आप लगो, टाइम के अकॉर्डिंग है. टाइम जितना रिवीजन हो जाएगा उतना ही आपके लिए बेनिफिशियल है. नेक्स्ट हम डिस्कस
हाँ सर
करते हैं
वही.
रिडॉक्स रिएक्शन क्या है. व्हाट इज रिडॉक्स रिएक्शन? redox reaction
Yes, sir.
बताइए.
If in reaction, that means oxidation and reduction taking place at the same time, then it is called redox reaction. Suppose I am taking copper 2 positive and zinc. Copper 2 positive is getting reduced to copper form, and zinc 2 positive is zinc is oxidized to Zn2 positive. That means in this reaction, the zinc loses the electron, and this electron is gained by that means which is called copper. This reaction, zinc is getting oxidized and copper is getting reduced, and this reaction is basically called redox reaction, in which reduction and oxidation take place simultaneously.
Yes, inner sphere, outer sphere mechanism. What the difference or
Yes, sir.
example?
Yes, sir. Sir, in inner sphere, that means inner sphere mechanism, the main point of inner sphere mechanism is that means the ligand, that means the complex, both the complex should be one complex should be labile and another complex should be inert in in inner sphere complex, inner sphere mechanism, and the we must have one bridging ligand. We must have one bridging ligand for inner sphere mechanism. Suppose I am taking one bridging example is OH minus, Cl minus, cyanide, carbonyl. These all can help the inner sphere mechanism. And for outer sphere mechanism, both the metal, both the complex should be inert in nature, and we don't need the bridging ligand. Only that means the electron can transfer through by only, that means one substance is getting oxidized and other substance is other complex getting reduced. That means one precursor complex is formed, one become reductant and one become oxidant. Yes, sir. That is the main difference between inner sphere and outer sphere. In inner sphere, that means the electron can transfer through only bridging ligand, but in outer sphere mechanism, electron can transfer if one complex lose that electron and another gain that electron. Yes, sir. That is the main difference between inner and outer sphere complex. Okay, sir.
One electron transfer, two electron transfer. What the difference?
One electron, no, sir. That I don't know. One electron transfer. I have forgot that thing, sir. One electron transfer and two electron transfer. No, sir. Can you please tell, sir, that one?
Yes, one electron. Yeah. ये अभी जो हमने डिस्कस किया यही है ना, इसी को आपको डिफाइन करना
हाँ,
है,
सर.
जो इनर स्फीयर और आउटर स्फीयर.
Sir, I think, sir, inner sphere में 2 electron transfer होता है.
Inner sphere is 2 electron, but outer sphere is 1 electron.
Yes.
ये अभी हमने डिस्कस किया यही है.
हाँ, हाँ, हाँ. Yes. I forgot that thing. Yes. That is the one electron transfer and 2 electron transfer.
फोटोकेमिकल रिएक्शन क्या है? व्हाट इज फोटोकेमिकल रिएक्शन?
Yes, sir. If that means those reactions which take place with the help of, that means photon, that means with the help of absorption of photon, then it is called photochemical. Then it is called photochemical reaction. Yes, sir. If it helps, if it, that means process through absorption of photon, then it is called photoelectron transfer, photoelectron reaction. Photochemical
एक्सप्लेन
reaction.
कीजिए, एक्सप्लेन.
Sir, that means what was it? 1 minute, sir. Yes, sir. रुथेनियम का एक था सर, रुथेनियम बाइपेरिडिन का कुछ एक था, जो जो याद है मुझे, रुथेनियम बाइपेरिडिन का कुछ था ये। दैट मीन्स इलेक्ट्रॉन ओनली पास थ्रू, दैट मीन्स लिगैंड ओनली, दैट आई फॉरगॉट सर। ये मतलब इतना डीप तक तो नहीं। ये अच्छा, इट इज
इनका का आपने ये
नो
अभी
सर।
इतना कोऑर्डिनेशन किया है, इसको बताइए, एक्सप्लेन कीजिए थोड़ा, कोऑर्डिनेशन के पॉइंट बताइए, 10-15 यूजेस क्या है कोऑर्डिनेशन के।
Yes, sir. Sir, coordination is basically used in for the extraction of metal basically. Suppose I'm for Mond process, that is nickel tetracarbonate is formed, or for the formation, that means in qualitative analysis, in ring test also we can get the coordinated complex. And I am taking in the biological system also, that chlorophyll, hemoglobin, myoglobin, all are of complex compound. And another thing is, sir, for the preparation of reaction, we use catalyst basically. Catalyst, that means Wilkinson catalyst for the hydrogenation reaction, and for polymerization, that is Ziegler-Natta catalyst. That is also the use of coordination complex in our treatment, sir. Yes, sir. और क्या था सर, और for the medicinal treatment, like in basic things, cisplatin is there for thyroid, that means thyroid also we use the coordinated complex. Yes, sir. For the extraction of metal, basically gold, silver, all are extracted by this process, and that means with the help of coordination chemistry we can extract all this metal.
Any other point? What the beneficial of coordination chemistry in human life?
बेनिफिशियल बेनिफिट तो यही होगा सर, मेडिसिन मेडिसिन वगैरह बनाते हैं, मेडिसिन वगैरह, और मतलब वाटर का ट्रीटमेंट वगैरह में
पॉइंट
भी यूज होता
बनाइए,
है
पॉइंट
वाटर का।
पॉइंट पॉइंट वाइज
यस
एक्सप्लेन
सर।
कीजिए, पॉइंट वाइज।
यस यस, दैट मीन्स for beneficial benefit of for coordination chemistry are basically from coordination chemistry we can make the medicine for treatment like cancer, treatment like thyroid, all these things. We make medicine from coordination with the help of coordination chemistry. With the help of coordination chemistry, we that means we remove the hardness of water also. With the help of coordination chemistry, we can catalyze all the reaction also. Catalyze, that means reaction, that means we can hasten the reaction also. Yes, sir. All the benefit. और क्या क्या हो सकता है सर? That means
एनालिसिस कीजिए, आपने इतना पूरा कोऑर्डिनेशन किया है, क्या क्या हो सकता है। स्टार्टिंग पहले कॉम्प्लेक्स से करते हैं, फर्स्ट ऑफ ऑल बेसिक से ही हम करें तो कॉम्प्लेक्स का यूजेस होता है, कॉम्प्लेक्स यूज किए जाते हैं, ठीक है। वर्नर थ्योरी है, वर्नर थ्योरी के अकॉर्डिंग क्या किया जाता है, एक एक पॉइंट के अकॉर्डिंग करेंगे। वर्नर थ्योरी का क्या यूजेस है बताइए, एक एक चीजों से एनालिसिस हो जाएगा।
वार्नर थ्योरी का तो सर यूज मतलब we can predict the structure of the complex from
यस,
Warner theory. That means arrangement. Yes, we can predict structure, or that means arrangement of ligand around the metal ion. We can predict by Warner theory. Yes, we can predict the primary. That means we came to know about the two valencies there. One is primary valency and one is secondary valency. Yes, from Warner theory only. Yes, sir. Then from crystal, that means valence bond
लिगेंड्स
theory.
लिगेंड्स का क्या यूज है,
We
लिगेंड्स से बताइए।
ligand that means ligand का क्या यूज होगा सर?
लगाइए यूज, क्या होता है लिगेंड्स का, कहाँ कहाँ यूज किया जाता है, आप बताओगे ना। और कुछ है ligand association? नो सर, ये अभी तो ये
ligand।
बात नहीं है, लिगेंड्स हो गया, उसके बाद आप आइसोमेरिज,
हाँ आइसोमरिज्म से हम लोग मतलब मेडिसिन वगैरह बना सकते